Hello, folks. Welcome to the Plain Mundane Show. I'm Alex Aquarius. Uh, I got up at 3:45 this morning and started making this video because I was laying in bed doing algebra in my head, and it wasn't even a nightmare. It's fun actually, and it's not that hard. So grab your calculator, and we're going to talk about the curvature of the Earth, and I'm going to make this formula simple for you. You've heard it is said that it's 8 inches per mile squared. To me, as a mathematician, per means divide by. So I don't say it that way. What I say is miles squared times 8 inches. In the upper left-hand corner here, I've got miles squared times 8 inches. All right, so we're going to look at the Statue of Liberty as an example. I looked on the internet and found out, I Googled the Statue of Liberty, the distance you can see it from, and it's said that you can see it from 60 miles away, and it's 326 feet above sea level. Okay, to the tip of the torch. So let's test that with our formula. So if we have miles squared times 8 inches, we'll take 60 times 60, which is miles squared in this case, times 8. Then we're going to get that number is going to give you a big number in inches. And if you want to know feet, just divide that number by 12 because it's 12 inches per foot. And you're going to get feet. You'll get 2,400 feet. Okay, so sea level will go down 2,400 feet in 60 miles. Now you want to add the 326 feet of the statue above that sea level in the distance. So what you do is you subtract it from 2,400, and you're going to get 2,074 feet below the level of the horizon on a spherical Earth with the curvature formula. So at 60 miles away over water, which is perfectly smooth and flat according to some and curved according to others, this is what we're busting. You should not be able to see the Statue of Liberty at 60 miles because the tip of the torch would be 2,074 feet below your level horizon from your perspective. And this math, folks, is not even including the angular momentum of decrease that this would have, because if it's on a sphere, as you get further away from it, you're not parallel with it, it's leaning away from you. So that's going to drop its height even more. We could probably add another factor in parentheses to this formula that would account for the degree of curvature in radians. But we're not going to go that far. This is just a bulk gross formula, okay? So the torch is 2,074 feet below your visual surface at 60 miles. Impossible. Now what I did with this formula, folks, I went ahead and solved it and reversed it so that you can use a new formula that I made up just now. I'll call it the Aquarius formula. To find the disappearing distance for any object, take its height in feet, multiply that number times 1.5. Then on your calculator, hit the square root button. Using the Statue of Liberty as an example, we take 326 feet, that's its height above sea level to the top of the torch. We'll multiply that number times 1.5, we get 489. Okay, now in your calculator, when you got 489 on the screen, just hit the square root button. You'll get 22.11 miles. That's when the tip of the torch goes over the horizon and the Statue of Liberty's gone. You can't see anything of it, not even the torch flame. Okay? Isn't that amazing, folks? You can do this with anything. You can measure, if you know the foot height of a building near you where you live, you can calculate the limit of how far away you should be able to see it, and you can drive that distance from it. Check it out on a map. You could probably use GPS or Google Earth and drive to that point and see if you can still see it and prove it to your friends. You can do this locally. You can prove this with the formula locally with your own landmarks in your own area where you live. Okay, on this other screen, I took some popular landmarks in the United States of the tallest structures. And I calculated the vanishing distance in miles for objects using their foot height. Okay, so we're going to look at the One World Trade Center, which is 1,776 feet. It's a very patriotic number in feet. Also the foundation date of that Bavarian group. Okay, One World Trade Center disappears at 51.6 miles. Now the way you do that is you take 1776 times 1.5 and hit your square root button. It's simple, folks. I know the name of this is algebra, but don't be scared. It's just a couple of buttons on your calculator. The Willis Tower in Chicago, 1,451 feet times 1.5, hit the square root button, gives you 46.65 miles away, and it's gone over the curvature. JP Morgan Chase Tower in Houston, 1,002 feet times 1.5, hit the square root button, it's gone in 38.76 miles. 432 Park Avenue in New York City, 1,396 feet. Multiply that number times 1.5, hit the square root button, 45.76 miles, and it's gone over the horizon. Trump International Hotel and Tower in Chicago, 1,389 feet tall times 1.5, hit your square root button, you're going to get 45.65 miles, and you shouldn't be able to see it. What is it, 49 miles across that lake to Michigan? It should be completely gone, you know, before you even get to the other side. Wilshire Grand Center, 1,099 feet. This is in Los Angeles. Multiply that number times 1.5, hit your square root key, you get 40.6 miles, and it's gone under the horizon. Columbia Center in Seattle, 967 feet tall times 1.5, hit your square root key, you're going to get 38.09 miles, and it's gone over the horizon. So there you go, folks. That's the easy formula. I showed you how to do it. Take any landmark near you. If you know its height in feet, calculate its distance that it vanishes in miles, and then maybe you want to go to that point, that radius from it. So let's say if your topography is relatively level, and that's not going to affect this formula. If it's even better if you got a boat and you're on water from it, and that should be where it disappears. All right, that's Plain Mundane Show for today. I'm Alex Aquarius. Please hit like and subscribe and ring the bell for notifications. Y'all have a blessed day.